HCH stands for hexachlorocyclohexane. It is a waste product that was generated during the manufacture of an insecticide sold under the name Lindane, used in farming and to rid cattle of parasites. For every kilo of Lindane produced, the process generated 9 kilos of HCH isomers with no commercial value. This waste was dumped with no control, usually on land close to the production site. Lindane production at the Bilbao Chemicals plant in Baracaldo, Vizcaya, ceased in 1987, but the problems arising from the dumping and lack of proper management of HCH waste in the Basque Autonomous Community persisted. As can be seen from the illustration, the waste was carried on the rain and wind, causing it to pollute surface and groundwater and the soil itself. Fumes released from these pollutants due to high temperatures also affected air quality in the area. Some of the affected areas are used for grazing and crop farming, and others are zoned for urban or industrial development. All these uses entail risks for human health and ecosystems. Over time, HCH waste dumps contaminated large volumes of soil, especially on the following sites. In the municipality of Portugalete, Rivas Viejo, with 8,778 cubic meters, and Polígono Industrial SIA, with 2,543. In the municipality of Sestao, Babcock Wilcox, with 5,987 cubic meters. In the municipality of Ortuella, Mina Orgonera, with 784 cubic meters, and Paraje Concha, with 1,092. In the municipality of Galdames, Paraje Lasigotti, with 3,126 cubic meters. In the municipality of Erandio, Neshana Selamerc, with 26,922 cubic meters, and Irinesa, with 2,604. In the municipality of Abanto, Cantera Matilde, with 9,104 cubic meters, and Paraje Meastegui, with 2,938. In the municipality of Lemoa, Cantera Basada, with 3,444 cubic meters. In the municipality of Carranza, Paraje Villanueva de Presa, with 615 cubic meters. In the municipality of Musquis, Mina Petronila, with 4,906 cubic meters. In the municipality of Baracaldo, Paraje Largatza, with 11,956 cubic meters. Idanor Bilbao Chemicals, with 78,788. Soloco, with 54,451. Las Julianas, with 2,352. Frade, with 62,530. Vega Galindo, with 43,286. Efersa, with 30,170. Camino Sirga, with 12,432. Bilbao Exhibition Center, with 5,306. Urban, with 4,974. And Errequeta, with 37,916. These last two sites were contaminated by heavy metals rather than HCH. The failure to manage HCH waste properly resulted in risks to human health and prevented the land affected from being used for agriculture and commercial or industrial development. To find a solution to this situation, the Basque Government Department of Land Use and the Environment asked the publicly owned environmental management company, EOBE, to study how other countries had dealt with similar problems. The points considered in seeking a solution included environmental impact, proven viability, technical effectiveness, and cost. In this case, the project was co-funded by the EU's Cohesion Fund. Several options were considered, and it was eventually decided to eliminate the pure HCH waste by a process known as BCD, which stands for base catalyzed dechlorination. And to confine the waste that was mixed with other substances and soil contaminated by uncontrolled HCH dumping in a safety landfill. This method had been tried and tested at international level and was also used by EOBE itself in the construction of the Loiu safety landfill, where a total of 113,118 cubic meters of HCH contaminated soil removed from land owned by Bilbao Airport was confined. In 1995, EOBE staged a public tender for the preliminary environmental impact study into the location of a safety landfill. The area to be considered extended through all the municipalities on the left bank of the Nervión River estuary and the mining area of Vizcaya, since it was there that most of the sites to be cleaned up by this project were located. Various options were identified, described and assessed, and the site finally chosen was Argalario, an area which was contaminated and severely run down. It housed the old Baracaldo municipal solid waste dump for the municipalities of the left bank and lay in the municipality where around 85% of the HCH contaminated soil was located. This study was subsequently backed up by another, performed at the request of the technical committee set up specifically for this project, taking the whole municipality of Baracaldo into account. The site selected was environmentally and structurally unsound. The waste from the old dump was unstable. There was pollution of ground and surface water, and noxious gases given off by the site deteriorated the local air quality. The project set up by the Basque Government Department of Land Use and the Environment, acting through EOBE, was ambitious in environmental and technical terms. Its goal was fully to recover the old dump site before the safety landfill was built. This was to be done in the following stages. The first step was to collect runoff water into a system of canals along the perimeter of the site, then to canalize the river Bortsaco, adapting it to a new course and sizing it in accordance with hydrological calculations. The instability of the waste in the dump meant that the internal water table had to be taken down by building vertical gravel drains. At the same time, a reinforced concrete containing wall was built, comprising 49 posts of 1 meter in diameter by 18 meters in height in front of the drainage columns, linked together by 3 transverse beams 69 meters in length, and attached to the natural ground by 38 anchors. When the containing wall was complete, the dump site was reprofiled with beams 4 meters wide, separated by 10-meter gaps. During the work, not only municipal waste, but also industrial and sanitary waste was found. Collection of leachates from the waste dumped at the site was greatly facilitated by the vertical drains built onto the back of the posts in the containing wall and a barrier-type collector along the foot of the wall. Leachates are carried in a reinforced concrete conduit measuring 1.6 meters wide by 2.2 meters high by 230 meters long. To prevent the air from becoming fouled, a 23-meter high stack was built at the end opposite the entrance point to ventilate the conduit. This conduit runs under the safety landfill and carries the leachates from the dump in a polythene pipe, which extends from the collector where the leachates converge to the treatment plant. A biological treatment system was designed on the basis of analyses of the leachates from the MSW dump and the Basque Government Water Department's requirements for discharges to sewers. As shown in the illustration, this system involves a nitrification process enhanced by bacteria in an oxygen-rich medium to turn ammonium into nitrates. The concentrations of the various substances to be tested for are checked, and if there is no problem, the water is discharged into the municipal sewerage system. Decomposing organic waste in the dump produces internal reactions which generate biogas, including methane and carbon dioxide. This essentially exothermic process is favored by moisture. Landfill gas can pose major environmental and safety problems for surrounding areas. It also migrates naturally through the various layers of waste in the dump and into the atmosphere, contributing to the greenhouse effect. The degasification system installed comprises a 30-centimeter layer of gravel over the whole top of the dump and a network of 14 wells connected via polythene pipes to a central exhauster unit. This unit generates a slight vacuum pressure which draws the biogas into a combustion system, where a burner eliminates it at 1200 degrees centigrade. Dump sites are capped for two main reasons: to prevent gas from the waste digestion process from getting out, and to prevent rainwater from getting in, thus reducing the amount of leachate produced. This dump is capped with the following layers of material, from top to bottom, including gas drainage layer. Geotextile separation layer, gas drainage layer, bentonite blanket, polythene sheeting, geocomposite drainage layer, layer of clayey soil, layer of topsoil. The scheme for blending the MSW dump into the surrounding area seeks to achieve two things: to improve the quality of the landscape at the site and to help stabilize the embankments, which have been hydro-seeded and planted out with native species of trees, particularly birch, thus completing remediation of the old Argalario dump site. Now let us move on to look at the building of the safety landfill itself. Some of this work was carried out at the same time as the remediation of the dump site, but it's described separately here to make it more easily understandable. A safety landfill is a structure in which contaminated materials can be confined and isolated to prevent them from damaging the environment. To ensure that surface and groundwater is protected at all times, these landfills are built with a series of sampling points and a continuous monitoring system in a control network. The landfill constructed here has a circuit of topographic bases to detect and monitor even the slightest movement in the waste it contains. Inclinometers are also installed to reinforce the measuring system and keep a check internally on the waste. Leachates from the various layers of waste are collected and carried to an adjacent treatment plant. Work to shape the safety landfill was carried out at the same time as work to stabilize the MSW dump. Before the work started, 39 oak trees and 6 holly trees growing on the site were uprooted and replanted at the top of Mount Argalario. Once the site had been excavated to the required depth, the ground was compacted to form a stable floor for the safety landfill itself and the bottom of the leachate conduit. The conduit and underground water drainage network were built, then the site was filled in with borrow and embankments were built with the slopes envisaged in the project. At the same time, the containing wall was set up, with a limestone rock fill being laid in the area through which the conduits ran. When construction of the confinement cell and containing wall was completed, the inside of the cell was sealed. The bottom of the cell is sealed, mainly to prevent contaminated materials from filtering into the soil. A blanket of bentonite and a sheet of high-density polythene are fitted to provide a double safety seal. The layers in the bottom seal comprise the filler material from shaping the cell, a geotextile separation layer, an ophitic leveling layer, drainage for underground water, a bentonite blanket, polythene sheeting, puncture-proof geotextile, a siliceous layer for leachate drainage, a leachate collection system, a geotextile separation layer, and the contaminated soil. Before excavation of contaminated soil could commence, adequate access roads had to be constructed. This involved building a bridge over the River Galindo to gain access to the Soloco Ibarreta area, and dynamite had to be used in some areas to reach the former dump site in Baracaldo. The contaminated sites were excavated in 3 phases. Phase 1 involved excavating and removing waste dumped on them. Phase 2 comprised the excavation and removal of the contaminated soil itself. The third and final phase involved using a clearing bucket to excavate and remove the top layer of non-contaminated soil to ensure full remediation of the site. The residual pollution levels after this process were below the target figures for the project. The trucks used on the excavation site carried containers only from the point of excavation to the washing station at the transfer platform. There, the outside of each container was washed, and containers were taken by forklift off the truck which brought them in and loaded onto another truck standing in a clean area. The contaminated and clean areas were separated by a dividing block. Once containers were on the truck, they were taken a short distance to another point, where covers were fitted and the safety system and seals were checked. Only then was permission for transportation given. On arriving at the unloading platform at the safety landfill, trucks tipped out the contaminated earth and were washed again at a purpose-built washing facility at the unloading point. The material carried was also checked at this point by means of a route sheet covering the whole operation. Once all these checks were completed, drivers were allowed to return to the start of the circuit. The HCH-contaminated soil unloaded onto the platform was loaded by a backhoe excavator onto articulated trucks operating inside the safety landfill. These trucks took it to its allocated confinement area, which was determined by the physical characteristics, moisture level, and degree of contamination of the soil. The soil was spread by a dozer blade to form tiers 50 centimeters thick, which were then compacted to the degree calculated as optimum using a roller. Geotechnical tests were then performed, and if all was well, a further tier was spread on top. Hardcore beds had to be laid at some levels to enable trucks to drive over the top of the waste.